Hope everyone's doing okay. Moving into the next topic here, we are going to start putting multiple lenses or lens mirror combinations. Those are going to be fun because you're going to have to go back to all your rules on the mirrors. But wanted to do a quick run through for a practice problem with a two lens system. I'm going to do one of the harder ones. Actually, the first couple of questions on your handout are much easier. And then the last question is going to throw a little wrinkle at you, and it'll be a little bit harder for you to figure out, but most of you should be able to get it. All right, so here's what we got. As you can see in the first diagram, and I'm going to go through just the sample problems. This is just a review here to start off with, but we have a double convex lens located at x equals 30 centimeters on this diagram. We have an object located at x equals 25 centimeters. Now, the lens has a focal length of 10 centimeters, so notice that I have the focal points drawn on here. All right, so if we draw our ray diagram for this, we have ray 1 travels parallel to the principal axis and refracts through the primary focal point on the opposite side of the lens. Ray 2 through the secondary focal point and refracts parallel to the principal axis. And then ray 3, our center of curvature ray, goes right through the middle of the lens. As we backtrace these, hopefully you guys know by now that this is going to form a virtual image, okay? That is upright and magnified. Now, once again, I'm doing this on a separate sheet of paper, so I didn't come out very close here. Since this is exactly halfway between the focal point and the lens, I should expect an image to form right at the focal point, which my calculations verify that. If we go down to calculate this, we have our equation of 1 over f is 1 over do plus 1 over di. My focal length is 10. My object distance is 5 centimeters because it's 5 centimeters from the lens. And then I get a distance of an image of negative 10 centimeters. So that means that the image is located, or should be located, right here at x equals 20 on this scale. Once again, it's a little bit off. That's okay. It's hard to draw these things on a piece of paper unless the lens curvature and everything is absolutely perfect. All right, now here's what we're going to do. We are now going to add a second convex lens with a focal length of 6 centimeters. And we are going to place that at x equals 40 centimeter mark. So now we have not only a refraction that occurs at the first lens, but then we have a second refraction that occurs in the second lens. One thing that makes these pretty easy is the image that's generated from the first lens becomes your object for the second lens. So you can technically just eliminate this lens now and then just place the object right here at x equals 20. Most likely you're like me, your first diagram is going to come out just a little bit off. If you are proceeding from this diagram to the second diagram, one thing I usually do is just move my image and place it in the location where it's supposed to be. Okay, that'll help clear everything up because you don't want to make a mistake here and be off and then compound that mistake when you add the second lens in. Okay, so let's go ahead and look at what the ray diagram is going to look like for this problem. And this is a lot of lines. I put them all on here. Okay, so just to go back and review. So here's our original object. Ray 1, parallel principal axis, and refracts through the focal point. Now, notice the focal point. This is the focal point of lens 1. I have also placed the focal point 6 centimeters to the left here and placed this one 6 centimeters to the right here. And that's for lens 2. So we now have two different focal points here. So ray 1, parallel principal axis, refracts through the original focal point. Ray 3 travels through the center of this lens. Ray 2 through this focal point, refracts parallel to the principal axis. If I would have drawn this perfect, everything would have matched up right here, because since the first image, it should be twice the distance from the lens. Once again, the top of the image should be right here at this point. So, which you're going to notice, I have this dash line kind of offset, but that's okay. All right, so going to the second one thing we have nice here is a couple of these rays that are already drawn are in the right spot for us. So what I did is I just took my original ray 2 and made that into ray 1. So ray 1 travels parallel to the principal axis and will refract through the focal point for this lens. So it goes straight through. And I went ahead and stole my ray 1 from the original one, and I made that into ray 3 for the second one, because it went through this focal point, which just happens to be at the center of this lens. So that made it easy for me, and all I had to do is just continue tracing it on through. Where these two intersect, that is where my image should be from the two lens combination. Okay, so even though we had a virtual image that forms from just a single lens, if I place this second lens in here, I would expect to have a real image form that is inverted, and it looks like it should be a little bit smaller than my original object, because my original object took up one line of this paper that I drew on, and this one is a little over half. Okay, so let's do the math and see how accurate this is. If I am somewhat accurate, I can't remember what that number is right now, so it looks like this is the 40 centimeter mark, and this is the 50 centimeter line here. This is 46. So if I'm accurate, I should be about halfway between 46 and 50, so around 48 centimeters approximately when I get done with the calculation. So we start off 1 over the new focal point, which is 6 centimeters, equals 1 over DO plus 1 over DI. Now notice that my object distance is now 20. You got to remember, we are now focusing on this lens, and my object is now the image that was generated from the first lens. So this is 10 here, and then another 10, so this is the total object distance of 20 centimeters. If I plug that in, I get 8.57 centimeters, and it's a positive answer, and that makes sense. It says that I'm 8.57 centimeters from the second lens. So my image is located at x equals 48.6 centimeters on this diagram. So I was actually pretty accurate, even though I was just drawing all of this stuff by hand. Now, once again, this image is smaller than the original object. So to find the magnification, I just need to multiply my two magnification equations. And I didn't write my equation, so I'll take a half point off of mine later. But remember, magnification is negative di over do. So what I did here is I have negative, and then my original magnification, my image distance was negative 10 divided by my object distance of 5, times a negative positive 8.57 divided by 20, and I get a magnification number of negative 0.857. So once again, my diagram actually came out pretty accurate, so my overall image height or magnification is about 85.7% of the original object, and it's negative, which means it's inverted, so the calculations work out great. Just a food for thought here, because you might run into a problem like this. Let's say we have an original diagram and I place this object out here. Now we know that the image is going to be located somewhere over here from this first lens. But if I place the second lens right here, I now have an object for this particular lens. That object, we haven't seen something like this before, since the object is now on the same side of the lens as what the image will form over here by putting that secondary lens in. We are now I'm going to get rid of that. We are now going to end up with a virtual object. Virtual object means that we're going to have to switch the sign on the object distance, and it's going to be a negative object distance since we're tracing it this direction. So that's just some food for thought there. So hopefully this somewhat made sense. Good luck going through the handout. One thing that I will just mention on the handout when you guys are drawing these, it is not, some of the problems start off with this, and then they go down and they ask you to sketch out the next lens or mirror. You don't have to re-sketch all of the original work. You can just simply place your object or your secondary object, which was the image from the first one. You can place it just on the scale in the location where it's supposed to be. So once again, you can kind of cheat a little bit. And even if your initial drawing is like mine and it's off, when you get to the second drawing, you can cheat. You can place the object where it's supposed to be. Okay? Good luck.